Starting with number 1, I am supremely confident that you can do this one. Oh, yeah, I am supremely confident that you can solve this problem on your own. So please do so now. More about it. I'm trying to get in the habit. F of -1 is? -2 because the number in the parentheses stands for the x value, so you go over to -1 and then down to the graph, and that's -2. F of 2 is approximately 2.9, 2.7, 2.8, whatever. Okay, for what values of x is f of x equal to 2? So that would be, you would like just draw an imaginary line here, and that equals 2 at -3 and 1. Yeah? -3 and 1. Why? Because that's where the graph crosses the line y equals 2. Okay, but it crossed it twice, so we need both answers. Okay, estimate the values of x such that f of x equals 0. So those are called the zeros of the function, and that's where it crosses the x-axis. And so that is at about -2.5-ish, -2.4, and this one is at about 1/2, 0.4, whatevs, okay? All right, and then the domain is the possible x value, so this graph goes from -3 to 3, and then the range is the possible y value, so it goes from -2 up to 3, okay? Good, well, just review of function notation and all that. All right, this one's going to be a little bit trickier, so let's start this together, okay? This may seem like a totally random thing. It's 2 plus h and 2 and h, and why are they using h's? And you might remember that there was one that looked like this where we had to rationalize the denominator in the first diagnostic test. That's no coincidence. This is a fraction that we're going to be messing with a lot, okay? So to figure this out, you have to first figure out what f of 2 plus h is. And the way you do that is you take 2 plus h and you plug it into the equation. Okay, so what is the equation?
2 plus h
cubed. So I'm going to figure out what 2 plus f of 2 plus h is. I have to figure out what 2 plus h cubed is.
Why did you throw f?
Because f is like telling me this is what I do, but then once I plug that in, then I don't need that anymore.
Why did they put it like?
They replace the y with f of x because they want to sort of have this sense of that you're taking this value and substituting it into the function.
Don't you also already know that?
Right, so you could just say this is y equals x cubed, and then just this, you know, it's the same thing.
But then why did I have to put them in the, like, the other equation? Like, I don't understand that. Like, that one I understand, like the f of x,
Okay.
but then why, I feel like, and it makes me think it's a variable.
Yeah, the f isn't a variable, it's just a notation. Yeah. And then what we're going to do is we're going to figure out what this is, and then we're going to figure out what f of 2 is, and then we're going to do the math with those things. We're going to go whatever this is minus whatever this is divided by h.
Okay, let's do it then.
Okay, so 2 plus h cubed, of course, means 2 plus h times 2 plus h times 2 plus h, right? So the first step in doing that, you would do what? Yeah, foil. So I'm going to just pick 2 of the 3 and just foil those together. And I'm going to do that very quickly. And I'm going to get 4 plus 4h plus h squared. Do you know the little pattern for that? Yeah? When you're squaring something, it's the first thing squared, and then it's these two things multiplied together and doubled, and then it's the next thing squared. So 2 squared is 4, 2h doubled is 4h, and then h squared is h squared. Okay? Okay, then I'm going to multiply this all by 2 plus h, and that's a little bit awkward because formuling doesn't work anymore because there's too many terms. So the first thing I'm going to do is I'm going to multiply all of these terms by 2, and then I'm going to multiply all those terms by h, and then I'm going to combine like terms if I have any. Okay? So all of them by 2 gives me 8 plus 8h plus 2h squared. And then all of them by h gives me 4h plus 4h squared plus h cubed. How do you guys feel about that? All right, and then I can simplify that, like I said, by combining like terms. What do I have?
H cubed
Okay, you're going to write it in the right order. H cubed.
plus 6h squared
Uh-huh.
plus 12h plus 8.
Plus 8. Okay, so that whole process is 2 plus h quantity cubed. Okay? All right, that was the hard part because figuring out what f of 2 is easy.
Don't you have to cube
Is
it?
it
Yep, you
negative?
just cube it. Oh, good question. No, I'm going to substitute it in there first and then subtract the answer. Okay? So, yeah, just take that and plug it into the x there. So 2 cubed is 8. All right, so now I'm ready to go. That's the sort of the prep work. So f of 2 plus h we figured out is h cubed plus 6h squared plus 12h plus 8. And then I'm going to go minus f of 2, which is
8.
8. And I'm going to divide that whole thing by h. And the 8's cancel, which is super fun because,
Right, just take H.
what'd you say?
Take an H out of there.
Nice. Now these 3 terms all have h's in them, so I can factor an h out of each term. So that's h squared plus 6h plus 12. And then since I factored out that h,
Cancel.
I can cancel this one here with that one there. And my final answer is h squared plus 6h plus 12.
Which then you can simplify more time. Well, do you need to?
No, I don't need to.
Yeah.
Like you want to try and factor it or something like that? Yeah, you could maybe try, but.
You don't need to find what each equals.
No, we're not, because this is just an expression, it's not an equation, it's not set equal anything, okay? All right, so all that nonsense kind of makes sense. I know at this point you're like, oh, what? But, you know, yeah? Okay, what are the chances that you guys can work on domains on your own? You need some help getting
Only
through
very
this?
little.
Huh? Very little?
Well, I don't know if my head would have to like, not, I couldn't just look at it.
Okay. So to figure out the domain of this function here, we are going to factor the denominator. So what does that factor into?
Negative 2x plus or minus 2 plus 1.
X
Or
minus,
sorry, other way around.
okay, apology accepted. X plus 2 times x minus 1. Okay, so when we're finding the domain, what we're really doing is we're trying to figure out what what values x cannot equal. So what values in this fraction can x?
Negative 2 and 1.
Good. Why?
Because
Can't
you
divide
can't put
by
0.
zero.
Right, because you can't divide by 0. And if I plug in negative 2, I get 0. If I plug in 1, I get 0. So that my domain is all x's except for negative 2 and 1. Okay? All right, so piggybacking on that, then we can look at b here. What value of x, if I plug it in, will give me 0 in the denominator? You know, it's shaking me off. No, nothing, yeah, because anytime you square a number, it's going to be positive, and then a positive number plus 1 is still going to be positive, so that's going to never equal 0. What's the other thing you have to worry about with domains? What else can't you do? Square root of, what can't you take a square root of? Yeah, negative number. But this is not a square root, this is a cube root, and you can cube root a negative number, right? So the domain of this is actually all real numbers. Because you're never going to divide by 0, and you're never going to square root a negative number. Okay, then considerably trickier is this one over here. We're not dividing by anything, but we are taking square roots. So if I look at this square root here, what's the biggest number for x that I could put in there and still be okay? 3? 3. 3.5? Well,
Well, so I mean,
3.9?
yeah, so I can't go past 4.
Can't go past 4. Can it be 4?
Yes.
Yes. Can you take the square root of 0?
Yeah.
Yes. Okay, so for this guy right here, this tells us that x has to be less than or equal to 4. Right? Okay. What about for this one right here? What are the values of x that'll give me a positive number underneath there?
Anything greater than 1.
Anything greater than 1? So like 5, because that's 25 minus 1. Yeah, anything greater than 1 is good. What else?
Less than 1.
Anything less than what?
Equal or greater than 1.
Okay, so you have the other one.
Or less than negative 1.
Right, less than or equal to negative 1, because if you square a negative number, then you get a positive, so you're okay there too. So this means that it has to be x could be greater than or equal to 1, or x could be less than or equal to negative 1. Okay? So how do you combine all of those into one single thing?
Just
Interval
The union.
Oh, right, but I'm kind of like getting contradictory information here, I guess is what I'm saying. Is this, I'm saying x has to be less than or equal to 4, but this is saying x has to be greater than or equal to 1. So those two things.
Two things where it has to be between this and that.
Right, but these two things, like, okay, so for this one, what I'm saying is for this, I could plug in 7, right, into this one, but this one I can't. So what I'm asking is who wins?
You have to combine.
So that's it, be in between.
but it's not going to be anything that.
So like, what's my overall final
Well,
answer to
less
describe
than
the
or
numbers that I could put into both of these
Less than or
things?
equal to 4.
Less than or equal to 4, yeah. Right?
But then you can't have.
Oh, but then you can't have,
Between.
So less than
Zero.
4.
between negative 1 and 1 is out, right? Okay, so that means less than or equal to 4,
More than or equal to 1.
What?
so the numbers that'll work are
Anything
They
less
can be
than
0.
less than or equal to 4, but it can't be like, I can't put in 0, I guess is what I'm saying, which is less than or equal to 4, right? So that means, okay, so let's go this way. That means I can go from negative infinity to negative 1. And I can go from 1 to 4. Is that true?
Yes.
Okay. And as long as I pick numbers from here, then it'll work for both of them. If I go bigger than 4, then this one fails. If I go in between negative 1 and 1, then this one fails. That's a little messy.
The hardest part was writing.
Right.
Mr. Eldridge, that college is going back, you have to send it, like, you have to send it.
Okay, you're going to send me a link or something? Okay. I'm going to change it. And write a true one.
That's pretty easy.
Be like, okay, look, here's the deal. Okay. How are the graphs and functions obtained from the graph of f?
I don't know.
Okay. So we're talking about transformations here, we're talking about stretches. and-
Upside down.
Upside down. Negative f of x is going to flip it over the x-axis, right? Okay, how about 2f of x minus 1?
It's bigger.
Which way? This way or this way?
Vertically,
Vertical stretch of 2.
and then down.
Huh?
He's going to the,
All right, and then how about C?
that's
Right.
Good. Inside parentheses, remember, is right and left, but it always has the opposite effect of the sign of the number, so this is actually going to go to the right 3, and then the plus 2 goes up 2, yeah? Do, 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 do. Oh, good. How do you feel about your just basic graphs? Not using a calculator, make a rough sketch
But that's the one that
of
goes like,
the graph. Goes like what? Yeah, okay, so x cubed looks like this. Okay? Which means that for b, x cubed plus 1 is going to be moved to the left 1, but have the same shape. Too fast?
We're supposed to be writing this down.
I don't know. Listen, learn. How about x minus 2 cubed plus 3?
Right, 2.
To the right, 2. Up 3. And that's going to be that little,
curve.
yeah, that has a fancy special name that we're going to talk about in this class. That's called the point of inflection. Okay, how about 4 minus x squared? What does the 4 do?
Up 4.
Up 4, because it's a positive 4. What does the negative do?
Upside down.
Flips it upside down. Looks like that.
We shouldn't put the 4 first like that.
Huh?
We shouldn't put the 4 first like that. It's confusing.
What does the graph of the square root of x look like?
Like a V.
Like a who?
No.
No, that's upside down.
I know that is.
Yeah, like I always think of like an upside down Nike swoosh.
Oh, yeah.
Yeah.
Square root.
That's a Nike
It
swoosh.
does not look like a Nike swoosh.
There.
You need a little like curve and
And then what if I go 2 times the square root of x?
then it's wider.
Wider?
Up, no.
What do you mean by wider? Yeah, like higher, yeah,
Yeah.
because, is that what you mean? So your
Yeah.
vertical stretch of
'Cause
2.
it's like-
Okay, so yeah, like for this one, the square root of 1 is 1, so you have that point right there, but for this one, the square root of 1 is 1, but then you multiply by 2, so it's up higher, yeah. Something like that. Those are kind of pretty. Good job, me. Very good job. Okay, how about negative, what are we on?
You're recording, remember that?
What are we on?
G.
G?
Wait, yeah. I don't know.
Thanks for answering.
Like.
Negative 2 to the x? Okay, so what's 2 to the, well, first of all, 2 to the x is what kind of a function?
Exponential.
Exponential function. What does a graph of an exponential function look like?
It like graduated and it like.
Yeah, so you can remember there's, the key point is if you go any number to the 0 power, you always get
0. Oh, sorry.
1. So it's going to cross the y-axis at 1. And then since this number is bigger than 1, it's going to be exponential growth. So that's going to get super, super tall, and that's going to level out like that, okay? But this is negative 2 to the x, and so it's going to flip it upside down and actually look like that. So this is 2 to the x, this is negative 2 to the x.
And that point it crosses is 1.
Right, the point that it crosses the y-axis is 1 or negative 1 if you're doing the flip one. Okay, 1 plus x to the negative 1. Okay, can we write x to the negative 1 in the regular way, por favor?
X no square root of x.
What?
No, sorry, 1 over.
1 over x, yeah. So this is 1 plus 1 over x. It would be a modern day miracle. What does the graph of 1 over x look like?
No idea.
Straight line.
It's gotta be up.
Nope.
Goes,
Goes down? Yeah, because as this number gets bigger, what happens to this fraction? It gets smaller. Okay, so it is going to go down, but when this number gets smaller, this number gets bigger. So it looks like this. Right? Does that make sense in your brain?
look at that.
Yeah, exactly. What a great looking asymptote. And there's 2 of them. There's one that's a horizontal asymptote at x equals 0. There's also a vertical, I'm sorry, at y equals 0. There's a horizontal one at x equals 0, okay? What about negative numbers? If I plug negative numbers into here, what do I get?
You just don't plug those in.
Oh, yeah.
No.
Flip it across the.
Flip it across the, so it'd be down here.
No.
You'd have it the other way.
Isn't it like opposite, like,
This?
isn't it completely flipped across the origin? So
Yes, it's completely flipped across the origin. Yeah, perfect. Because if you plug a negative number in there, you get a negative answer, right? So if you plug positive numbers here, you get positive answers. So these are all going to be in the first quadrant. If you plug negative numbers in here, you get negative answers. So those are all going to be in the third quadrant. So this is always a graph of 1 over x. What happens if I go 1 plus 1?
Just move it up one.
Just move it up 1, yeah. So this horizontal asymptote, instead of being there, becomes there. So it looks like this. And like that. Okay?
Oh, no.
Wait a minute.
Half an hour? Well, I'm going to give you about 25 minutes. And when the phone came out, I just did that. So,
I'm not done.
you just said you're up there.
No, I'm not. I'm not.
Okay. Okay, we good there with all those graphs? You guys kind of recall those? Remember we talked about the 10 basic functions last year? We did that, right?
Yeah.
Why? I don't know. Why not? Maybe there's people out there that need to learn and they need my help, so.
Yeah, but they're not in our classroom.
Right, that's why I have to record. So put it on YouTube and then
So you're
everyone.
putting that on YouTube.
Absolutely.
This is our
Yeah.
podcast.
So, hello world. What am I adding
Let me
here?
hold the mic.
6.
I need a grid. Oh, there it is. A long summer. Did you know that Pope William is just starting today?
Yeah.
In
It
Aberdeen?
feels like
That's
we
not
never
good.
stop.
I know, isn't it weird?
And it's only been 3 days.
Yeah, I totally agree. I don't know if it
Came in first.
feels that way like, I don't know if it feels that way every year. or-
Yeah,
It's the worst this year.
Do you think it's worse than normal this year?
But-
really did
Do you think it's worse than normal this year?
Yeah, because we had late, we were trying before Labor Day.
You know what?
Labor Day was also late.
This is,
Right.
yeah, but still off to the.
We got screwed because they're like,
What?
oh, but
They
they
might
might restart earlier to get out.
But we really don't.
Either way, we get out early anyways, so it's not
Yeah,
like.
same number of days for everybody, so that doesn't really matter. Okay, so this is a piecewise function. I don't know if you remember that, because there's 2 different pieces. One of the pieces looks like 1 minus x squared when we're talking about x's that are less than 0, and the other piece looks like 2x plus 1 if x is greater than 0. Unfortunately, we're going to play around with these a lot in calculus because you can do weird things with these to sort of like point out concepts that normal graphs don't usually display, okay? So we're going to practice a little bit making these graphs. So the first piece is 1 minus x squared. What does the graph of 1 minus x squared look like?
Upside down, it's moved up one.
Right, upside down, moved up 1. So I'm going to cheat a little bit and I'm going to put that right here.
That's gonna be 1.
And this is only for x's that are less than 0. Okay? So I'm only going to graph the piece to the left. So it's going to cross the y-axis at 1. Where does it cross the x-axis?
Wouldn't it be a... Shoot, I don't know. 1?
Jared? -1, yeah, because if you plug -1 into here, -1 squared is 1, and 1 minus 1 is 0. So it would cross the x-axis over there at -1.
Why
Okay?
can't
Why
you
can't
graph
this
both
be 1?
sides?
Why can't what?
Wait, what did you just say? How does it equal 0? Is that what you said?
Yeah, so to find out where it crosses the x-axis, you can basically just take the equation and set it equal to 0. And if you add x squared to both sides, you get 1 equals x squared. So your answers are x equals plus or minus 1. But
Okay, you said plus.
we're only messing with the negative side, so we're going to leave that alone.
You could graph both sides.
Why?
You could graph both sides, so the other side would look, like that. But this says x is less than or equal to 0, so I don't want that right-hand side, because the right-hand side is reserved for the function 2x plus 1. So what does 2x plus 1 look like?
Y-intercept at 1.
Y-intercept is at 1, so conveniently that's right there. And then the slope is 2,
X is greater than
so up 2 over 1, up 2 over 1, so it looks like this. Okay, so there's my wacky looking piecewise function. 2 pieces, half a parabola, and then half of a linear graph. Okay? Okay, so we got kind of a little bit ahead of ourselves. Part A said to evaluate these things first, and then I just got all excited and just made the graph, but we didn't have to. The key to this is if I'm going to substitute in -2, which of these two functions do I put it into?
The first one.
Why?
Because it's gonna be less than.
Right, because this is for values of x that are less than 0, and -2 is less than 0, so I put it into here. So what is f of -2?
5?
No, negative.
-3 because you're subtracting. You went one, but it's because you have to square it first and then
Oh,
subtract.
then the negative.
Yeah, so the negatives don't cancel and then square. So this is going to be -3. So f of 1, which one does that go into? Bottom one. So if I plug a 1 into there, 2 times 1, yeah, okay. Just for funnies, I know it doesn't ask this, but if it asks for f of 0,
First one.
right, you plug it into the first one because that's less than or equal to. And now, you know, you get the same answer for either one, so it wouldn't really matter, but just so you know, that's the one you would use. Okay? Oh, boy, this is going to be
I
fun.
hate these things,
Oh,
no,
long time.
I hate these.
Yeah.
Fog and golf?
I don't even remember this.
All right.
Oh.
So remember, because that little open circle there, in this case, does not mean multiplication. Okay, yeah, it's of, and that's what it's all about, is understanding that it is of. That f with a little thing there of g means f of g of x. So what that means is I'm going to take the g of x function and I'm going to substitute it into the f function, yeah. So every x in the f function is going to be replaced with 2x minus 1. So x squared becomes 2x minus 3 squared plus 2 times 2x minus 3 minus 1. Okay?
And we don't have to solve that, right?
Oh, heck yeah, we do.
But
Because this would give us a good opportunity to practice our very quick squaring that we talked about in the previous example. 2x minus 3 quantity squared is,
2x squared.
nope,
2x.
4x
Nope.
squared.
4x squared. Because you have to take the first term and square it, so that's going to be 4x squared. Minus 12x, multiply these together and then double it. Because there's going to be 2 of them, one for the outside, one for the inside, so minus 12x, and then plus 9. Okay? And then distributing the 2 is piece of cake, 4x minus 6, and minus 1.
Just go like, project in extra classes.
Okay?
I have a lot of pictures. Actually, let's talk to you.
So if you put fx, so
Right.
you put gx in fx.
Yeah, so now for the other way around, because you have to kind of read it, it says g of f of x. So I'm going to replace all the x's in the g function with the f of x function. So we guys do that on your lonesome rotten lamb.
Right now.
Okay, it looked like most of you guys got, or all of you guys
Oh,
got
that one
this.
does not look fun.
No.
Yep.
So that comes out to be 2x squared plus 4x minus 5. Okay, last one is triple shot mocha. G of G of G, I don't know. G of G of G of X.
plug it
So,
in.
yeah, so first thing you do is it's like inception, so you plug it into itself. Okay? So I'm gonna go G of 2, and then I'm gonna replace this x right here with 2x minus 3.
So then you gotta put the x minus, you gotta put 1.
Right, and then I'm gonna put that into, yeah, but I'm gonna simplify this first.
Oh, I didn't, is it alright if you don't do that?
I think so. Do you do that all in your head? I think so. So this works out to be 4x minus 6, right? G of G is 4x minus 6, because if you put 2x minus 3 in there, then, yeah. And then now I'm going to take that 4x minus 6 and plug it into,
Wait, don't you go 2x minus 3?
right here.
Yeah, don't you need another minus 3 in there?
Oh, yeah, you're right. Is that what you're saying? Okay, yep, you're right.
That's what you got. Did you do it this way?
You did it, you added
So we
it
got the
together,
same
but.
No, I don't
No,
think I
you
did.
didn't.
No,
You
because
forgot
that's
the minus
still,
three.
I forgot the minus 3, yeah, thank you. Okay, so that comes out to be 4x minus 6, but then you're right, I have to subtract 3, so that's 4x minus 9.
Yeah.
Okay, good call. Now I'm going to take that and plug it into the g function ultra base.
Okay, wait, so you plug that into the G function or the other one, or the G
No, I
function?
take my answer and plug it in for the x in the g
Okay.
function. So 2 times, this time, 4x minus 9. Don't forget the minus 3.
What, you could go.
And that gives you 8x
8x.
minus 18
This is 21.
minus 3, which is 8x minus 21. Did you get that? Was that
Yeah, I did it
right?
a different way though.
How'd you do it?
Should I come up there and show you?
Sure, if you want to. Can I give you a new slide?
Nah, I can do it right now, I'll just show you. I can do it.
No, there's not enough room there.
It's really not that much different, but I literally just wrote this and it's all good.
Oh, okay.
And just solve that through.
So you just wrote it all out in one
Yeah.
step?
And
Okay.
then made it solve through.
Right.
And then-
Yeah, that makes sense. Yep. Cool beans. Okay, questions? All right, one more. So I'm gonna let you, let's see if there's any chance that you can do this part on your own a little bit. Oh, yeah. So will you guys work on this as your assignment
Oh, I
today?
left that in my other one,
That's the other one.
my degree ratings.
Pi over 180 over pi, remember that? Okay. Remember the answers are right there for you, so if you can try them and then see if you
How
got
do
them
you go
right.
from,
From degrees to radians, you multiply by pi over 180. From radians to degrees, you multiply by 180 over pi.
So degrees to ratings is 180, it's pi over 180.
Yeah.